GGBS or ground blast furnace slag is a cement material used mostly in concrete, and it is a product for explosive furnace for the production of iron. Furthermore, GGBS is a cement material used in the production of iron. The bubbling furnace has a temperature of around 1500 Celsius and is supplied with an iron ore, coke and limestone mixture. The iron ore would then be reduced to iron and slackened on the iron forms. The other ingredients. Sometimes the slag is tapped like liquid and must be extinguished immediately in large quantities of water for handling of GGBS. Dalam bahasa Melayu, GGBS adalah hasil penyulingan besi dan keluli dengan air ataupun wap air dengan meniup tungku untuk pembuatan barang berbutir kaca yang kemudian diikat dan digiling ke sebuah halus yang terbentuk oleh kepupusan terak besi cair. Then GGBS is used for creating lasting concrete buildings in conjunction with ordinary Portland cement and other pozzolanic materials. In combination with ordinary Portland cement or other pozzolanic materials, GGBS is used for constructing durable concrete structure. GGBS has been widely used in Europe and increasingly in the United States and Asia, especially Japan and Singapore, for its superiority in concrete durability. It is also can extending the longevity of buildings from 50 years until 100 years. Concrete made of GGBS cement is lower than cement made of ordinary Portland cement based on the amount of GGBS, but also seems to be better over longer periods of time in manufacturing conditions. The new white GGBS cement colors allow architects to achieve light color without any additional fee, as opposed to the stony grey concrete made from Portland concrete. For the light paint finishing, GGBS is usually specified at 50 to 70% substitution level, but 85% can be used. GGBS berkesan untuk mengelakkan pembungaan pada tahap pergantian 50% sehingga 60% kerana kandungan kapur jauh lebih rendah dan kebolehtalapan yang lebih rendah.
Material properties. Application widely used in Europe, extending the life of buildings from 50 years to 100 years. Portland blast furnace cement and high slag blast furnace with GGBS content usually ranging from 30 to 70%. Concrete made from GGBS cement sets more slowly than concrete made from ordinary Portland cement. Material use. GGBS cement can be applied to concrete along with Portland cement, aggregates, and water. GGBS slightly less costly than Portland cement. Durability. GGBS provide against both sulfate attack and chloride attack. Longevity of GGBS can be significantly improved. GGBS used at a replacement level of 50% in concrete to defend against chloride attack. Composition. Grade 80 has a low index of operation and is mostly used for mass. Grade 100 has a moderate activity index with respect to cement behavior. Physical properties, which is air-cooled blast furnace slag, expanded blast furnace slag, granulated blast furnace slag, and pelletized blast furnace slag. Air-cooled blast furnace slag is crushed ACBFS, is angular, approximately cubical with texture ranging from rough to smooth. Expanded blast furnace slag is the angular, approximately cubical form of the crushed expanded slag, has a rougher texture than that of air-cooled slag. Pelletized blast furnace slag, smooth texture and a rounded form, unlike air-cooled and expanded blast furnace slag. And last, granulated blast furnace slag, glassy granular substance that ranges from a coarse popcorn-like friable structure. Thank you.
So, ni manufacturing process of GGBS ni. So, first kali select form when iron ore is melt and reduced into molten pig iron in blast furnace. Okay, lepas tu the amount of slag generation is roughly 300 kg per ton of pig iron produced. Then blast furnace slag is divided into air-cooled slag and granulated slag. Okay, dibahagikan kepada air-cooled slag dengan granulated slag. And then the former is produced by letting molten slag cook in open pits or yard, and the latter by rapidly cooling molten slag with water jet. The form looks like crushed stone, batu yang hancur, and the leather like sand. Itu lah. Okay, and then cost aggregate of blast furnace slag for concrete mixing is produced by crushing air-cooled slag, and then screen, and then fine aggregate is produced by lightly crushing granulate slag to control the grain size and the classifying. Ini pula untuk standard testing untuk GGBS ni. So gambar yang pertama ni kita tunjuk parts of the blast furnace ni. Dan gambar yang kedua ni gambar process in blast furnace ni. Okay, untuk process in the blast furnace, okay, the charge is introduced into the furnace through the cup and cone arrangement, and then simultaneously a hot blast of air is introduced into the furnace through the tires. Combustion of coke ni, the coke present in the charge burns in the hot air produced. Carbon dioxide generation more heat. Yang keempat, the carbon dioxide form rise up and reach the incoming coke, forming carbon monoxide. Then reduction of hematite. Carbon monoxide form is a powerful reducing agent. It reduces hematite to iron, and then the combustion of limestone due to the heat. Limestone decomposes from calcium oxide and carbon dioxide. Okay, untuk process of material application of GBS ni, so kita pakai material application dia ada 4. Yang first kali air-cooled blast furnace slag, yang kedua expanded blast furnace slag, yang ketiga granulate blast furnace slag, yang keempat laterized blast furnace. Okay, untuk air-cooled ni, okay, test for iron unsoundness when the slag contains more than 3% ferrous oxide and at least 1% total sulfur dia. And testing is conducted by immersing pieces of slag in water for a period of 14 days and observing whether any of the particle crack or disintegrate. So they minimize the potential for calcium sulfide dissolution by limiting total sulfur content to a maximum of 2% and total acid soluble sulfide to a maximum of 0.5%. Monitor and then last kali monitor and maintain the moisture content of ACB air-cooled ACBFC air-cooled blast furnace slag stock built above sanitary surface dry, itu SSD. Regularly test for unit weight per specific gravity. Untuk expand place pula, if the molten slag is cooled and solidified by adding controlled quantity of water, air, or steam, the process of cooling and solidation can be accelerated, increasing the cellular nature of the slag and producing a lightweight, expand or foam product. Foam slag is distinguishable from air-cooled blast furnace slag by its relatively high porosity and low book density. Untuk pelletized blast furnace, if the molten slag is cooled and solidified with water and air culture.
Pada hari ini saya akan membincangkan tentang ground granulated plus furnace slag ataupun lebih dikenali sebagai GGBS. GGBS ini sesuai untuk menggantikan Portland cement, iaitu simen biasa, kerana ia mempunyai kekuatan yang lebih kuat berbanding daripada Portland cement. Dia disebabkan oleh kandungan kalsium silicate hydrates yang lebih tinggi berbanding Portland cement. Jadi ada beberapa benefit yang saya boleh keluarkan untuk GGBS. Yang pertama, lower temperature rises in early age. Ini adalah untuk mengurangkan risiko retakan daripada faktor terma. Yang kedua ialah minimizes the risk of harmful internal reaction seperti alkali silica reaction dan juga integrated formation. Kelebihan yang ketiga ialah high resistance to chloride increase. Disebabkan dia high resistance untuk chloride increase, dia dapat mengurangkan corrosion of steel reinforcement. Yang keempat, high resistance to sulfate and other chemical attack. Apa yang dapat disimpulkan ialah GGBS ini adalah better workability, easier placement and compaction. Selain itu, GGBS juga mempunyai sustainable benefit, iaitu low embodied CO2, produce low CO2 concrete, no mineral extraction, and lastly, reduce landfill. For the future recommendation, we suggest to run the durability test of ground granulated plus furnace slag, which is GGBS concrete, and the corrosion behavior of reinforced concrete beam under various loading ratios.
As a conclusion, GGBS or ground granulated blast furnace slag is a good cement replacement and operates efficiently in certain cases, as we demonstrate, but it cannot replace cement totally. However, though replacing it partly, the results are very successful, and the building and sustainable development approach that we engineers are keen on today offers a greener approach. In the design and construction of high quality cement paste, mortar and concrete, GGBS is very helpful. Furthermore, the improvement in strength for cement replacement at age of 30% at 7 and 28 days is observed in GGBS based concrete. The replacement of cement by GGBS not only increase the compressive strength but also reduce the cement content, which decrease the emission of gas carbon dioxide. With respect to price, GGBS are 3 times smaller than those of ordinary Portland cement, both for processing or transport. So that it shows that GGBS is the best cement replacement to be used in the future. So I hope you enjoy watching this video. See you again.